Photogrammetry. The film was prepared by a team from Poznan University of Technology as part of the Recover IND project. Photogrammetry is a technique for obtaining measurements from photographs. It is used for digital mapping of objects and can be a tool to assist with building facade inventories. Start by taking photos and videos of the building. When taking pictures, the weather should be without intense sunlight on the photographed area. Take photographs and/or videos with a digital camera or mobile phone without flash. As much of the facade as possible should be in the frame in each photo. Avoid close-ups. Take a photo from different angles and distance to the elevation. If possible, take photos from a drone. Measure dimension on the elevation for later scaling of the scan. Upload files to a computer. You can use your photos to convert flat images into a virtual 3D point cloud. Various programs can be used to convert photographs into a 3D model. Some of them are free or offer a free educational license. You can download the program as a 14-day trial or as a free version with a limitation to process 50 images. This tutorial is about using 3ds for free. After uploading your photos to your computer, open 3ds. From the main menu, select Workflow and then New Project. To upload photos, click Next, and in the next window click the plus icon. Select the images and then click Next. If necessary, you can add or remove photos from the list and modify the calibration. If you don't want to change anything, click Next. For the building facade inventory, select the Urban and Deep Presets category. Then click Next. To start the reconstruction, click Run and wait for the process to finish. This may take some time. When the process is complete, you can see a list containing which photographs have been used and which have been discarded. If a lot of photos were rejected, analyze them, and compare them with the ones that were selected. If necessary, take additional photographs and repeat the process from the beginning. Then click Finish. This is the first result of the photo analysis. You see the white points of the 3D model and the blue symbols that show the positions and orientation of the camera. The next step is to make a dense point cloud. From the main menu, select Workflow, then Advanced, and then Dense Point Cloud Generation. Select all cameras and click Next. For the building facade inventory, select the Urban category and High Details presets. Then click Next. To start the densification, click Run and wait for the process to finish. This may take some time. Then click Finish. This is the second result of the photo analysis. You see the dense point cloud. The next step is to create mesh. From the main menu, select Workflow, then Advanced, and then Mesh Extraction. Select all cameras and click Next. For the building facade inventory, select the Urban category and High Details presets. Then click Next. To start mesh creation, click Run and wait for the process to finish. This may take some time. Then click Finish. This is the 3D mesh result. The next step is to define the vertical direction. Click the left mouse button and move the mouse to rotate and scroll to scale. Rotate the view so that you can see the vertical corner clearly. Select the arrow icon to define an up vector. You can choose different tools. I suggest you choose Axis. Click at 2 points on the edge of a vertical corner. The model will set itself automatically. This is what the model looks like when set up vertically. You can check the correct orientation by rotating the view. The next step is to scale the model. You should measure the actual model when taking the photos. 1 or 2 measurements are enough. In this example, the width of the window was measured. Rotate and scale the model to see the window straight ahead. Click on the icon with a ruler and an eccentric. To measure the distance on the model, click at 2 points and read the value. Then calculate the scale. In this example, the calculated scale is 0.48. From the main menu, select Tools, then Workspace, and then Scale. Enter the calculated scale value and click OK. Measure the window width again to check if it is scaled properly. You can export the model in various formats. In the main menu, select Workflow, then Advanced, and then Export Mesh. Find out what file format you can import into your BIM modeling software. In this example, I will show how to use the E57 file. In the Export options, select the E57 file format and click Save. Enter a file name and save. Save the file also in Zephyr format. You can open the file in E57 format using ArchiCAD by Graphisoft. To open this file in Revit by Autodesk, you must first use Recap. Download and install Autodesk Recap. A free educational license is available for students and teachers. Open Autodesk Recap. In Recap, create a new project and then select to import the point cloud. Enter a name for the new project and click Proceed. Then click on the plus icon to select the E57 file to be imported. Select the E57 file format from the drop-down list and select the prepared file. Click Import Files and then Index Scans. Click on Launch Project. This is the dense point cloud imported from the E57 file. Save the file in RCP format. This file format can be opened in Revit. Download and install Autodesk Revit. A free educational license is available for students and teachers. Open Autodesk Revit. Open a new file. Select an architectural template. On the Insert tab, select the point cloud icon. Select the prepared file in RCP format and open it. This is a dense point cloud imported into Revit. Use the Rotate tool to align the model parallel to the main axis directions. Open the 3D view. Open the facade view. Move the model and change or add the levels if needed. Open the horizontal view. Change the height setting of the view and properties if needed. Create the vertical section view in the area of window and change the depth of the view. The depth of view should be very small, then there will be little distortion in the view. You can use the shape to create the virtual twin. Thank you for your attention.